We're continuing on with our discussion of probability. We've talked about events already. We know that we have things called simple events and just events. So a simple event is anything that can be broken down as small as possible, such as when we roll a die, we could get a 1, or we could get a 2, or a 3, or a 4. Where events are can be a combination of our simple events, like rolling an even number or an odd. And that's what we're going to talk about in this lovely video. So for example, if we're rolling a 20-sided die, we know that our sample space are the numbers 1 through 20. And this is about this time, I think. Why did I say a 20-sided die? 17, 18, 19, 20. Okay. And we usually put our sets of numbers, our events, in the curly brackets. So we're just going to list the events, right? Which numbers are at least 12. So at least means the smallest it can be is 12. So we're going from 12 all the way to 20. At least and at most include those numbers. 16. Perfect. Now which numbers are at most 5? So the most it can be this time is 5. And which numbers are between 8 and 16 inclusive? So inclusive means, just like it sounds, it includes. So we're going to have the numbers all the way from 8, including 8, up to 13, 14, 15, to 16. There we go. So those are events. They're not simple events because a simple event would just be rolling a 12. These are a combination of simple events. And that is what we call a compound event. When we're doing a compound event, instead of doing at most and at least, if we have something like this, if we have A or B, what that means is in a single trial, either event A occurs or B occurs or both occur. Such as, what's the probability I'm going to go to Target or buy something today? So I could go to Target, I could buy something today, maybe not at Target, at Amazon, or I could do both. I could go to Target and buy something at the same time. When we're finding this probability, remember everything has to be equal, fair. That was one of our rules when we first started talking about probability. So we have to find how many ways A occurs and how many ways B occurs, but find it in such a way that no one or no single item is counted more than once. That way it's fair. To do that, we have to know if something is mutually exclusive. Sometimes you'll see it as disjoint. That just means that they cannot occur at the same time. For example, I have dogs and cats. So at my house, if you wanted to find the probability of selecting an animal at random, I would either get dog or I would get some cats. There's nothing in the middle where they would both be a dog and a cat at the same time. For that, unless you're an old show on Nickelodeon, right? For that, this idea of it overlapping, that's like my idea of going to Target or buying something today. If it overlaps, this means I'm going to Target and I'm going to buy something. All right, so what we want to do is if we were going to find the probability of going to Target or buying something today, I would need to find what's the probability of Target. So I'd find all this. Then I would find all of this, buying something. But what I want to do is I'm going to get rid of that because that way I'm only counting it one time. Two things that are always mutually exclusive are it's an event and its complement, right? If I say what's the probability of snowing, it could be, well, today it's maybe 5%, 2%. It's cold outside. But if I say what's the probability of it's not snowing, right, I can't have both. So those are always going to be mutually exclusive. So that might be the hardest part, finding this idea of being mutually exclusive or not. So let's do an example. Selecting a person that is taking statistics. Selecting a person that is taking English. Well, you can do both, right? You can be a student that takes statistics on Monday, Wednesday, Friday, and English on Tuesday, Thursday. So this is not mutually exclusive. Selecting a 12-year-old, selecting a licensed driver. I don't know of a place in the United States where a 12-year-old can be a licensed driver. So we would say that is mutually exclusive. And selecting a card that is a heart, selecting a card that's a queen. Well, this is not mutually exclusive. I can select a card that is a heart and a queen. It's called the Queen, the Queen of Hearts. If our concepts are mutually exclusive, such as selecting a 12-year-old, selecting a licensed driver, then what we're going to do is we're just going to find the probability of each event and add them together. For example, H is a heart, F is a face card, C is a club. Is having a heart and a face card mutually exclusive? No. You can have a Jack of Hearts, a Queen of Hearts, and a King of Hearts. So not mutually exclusive. What about a heart and a club? Well, you can't draw one card and it both be a heart and a club. So yes. What is the probability of drawing a face card that's a heart? So face and a heart. Well, we just saw that there were 3 out of 52. And 3 out of 52 is 0.0577. What's the probability of not drawing a heart? So not a heart. What we use is our rule of the complement, right? Not is our complement rule. So 1 minus the probability of a heart, and there's 13 out of 52 hearts. So that is 0.75. What about drawing a heart or a club? Well, we said hearts and clubs are mutually exclusive. So heart or a club, we would just add those together. So that wording is really important, right? We have to have or means we're just going to add them together, and means we're looking at what they have in common. So hearts, we have 13 out of 52. Clubs, we have 13 out of 52. And that's 0.5. Now, like I said, if I wanted to know the probability of a target, going to target or buying something, can't count going to target and buying something, right? That would be counting it twice. So what we're going to do is subtract what they have in common. Let's roll a die. Our sample space is 1, 2, 3, 4, 5, and 6. Even will be 2, 4, 6. Odd, 1, 3, 5. And at most 4 would be 1, 2, 3, 4. So those are the events. I want to know the probability of being even and at most 4. So and means occurring at the same time. So I'm going to look at my 2 sample spaces of those events and see what they have in common. And notice they both have a 2 and a 4. So there's 2 events out of 6. We always divide by our sample space. And the probability is 0.3333 of getting an even number and a number that's at most 4 at the same time. What about even and odd? Well, we look at our 2 events. Notice that there's nothing in common. There's 0 out of our 6 out of our sample space that is both an even and an odd. You can't do it. It's impossible. Okay, now even or. So or means to add. Or always means to add. If you see the word or, you should add. Or means to add. E or F. So the first thing you have to do is look to see if they have anything in common. And we know that they do. So we're going to use our rule that says take E, take F, and then subtract what they have in common. So or means to add, but we have to subtract what they have in common. So E is even, which is 3 out of 6. At most 4, there's 4 out of 6, and we know that there's 2 out of 6 that they have in common. So that is 5 divided by 6, which is 0.8333. Even or odd. Or means to add. We know that they are mutually exclusive. They have nothing in common. So that would be 0 out of 6. I'm sorry. Doing and again. Or means to add. So we're going to take our probability of even, which is 3 out of 6, our probability of odd, which is 3 out of 6, and is certain that we're going to, when we roll a die, get an even or an odd number. One more, the at most 4, but not that, so we know it's 1 minus the probability of at most 4. There's 4 out of 6 that are at most 4, so that's 2 out of 6. And we know already that that's 0.33333333333. So basically, in a nutshell, when you see the word not an event, it's everything that's not that event. So if I have 30 students and I go like, how many students don't have brown hair? That's what not the event means. A and B, that would mean, for example, female and having brown hair. I want to know both of them. They have to be both. So just because you're female, if you don't have brown hair, you're out. It's got to be female and brown hair. However, if I said female or brown hair, that means I want all the females or brown-haired people or both, right? Female or brown. I like thinking of my coffee, right? When I drink a lot of coffee. When it says and, like when waitresses say, would you like milk and sugar with your coffee? No, I don't. I like it black. So, but milk and sugar means they're all mixed together. Milk and sugar is mixed together. You can't separate it. But milk or sugar, that means I could have the milk, or I could just take sugar. That's how my husband takes it. Or I could put both, right? Milk or sugar means one or the other or both. All right, that's it for our ideas of events. Come back and we'll do some more examples later on.